Question 12. The diagram shows a cross section of 7 cylindrical pipes, each of radius 20 centimeter, held together by a thin rope. The center of the outer pipes are A, B, C, D, E, and F. Points P and Q are situated with straight section of the rope meet the pipe with the center A. In the first part, we have to show that angle PAQ is equals to 1 upon 3 pi radians. Now, one of the ways to show this is that as there are 6 circles around the center circle and they are symmetrical, so the total angle of a circle is 2 pi. So we'll divide this angle by 6, which will give us 1 upon 3 pi radians. Another way is that, let's say if I draw a line from A to F, and then another line from A to the center point of this circle, and then another line from the F to the center point of this circle, we can see that each of these lengths will be equal, as the radius is 20, so each of these lengths will be 40 each. Now, as they're equilateral, so the total angle in a triangle is pi radians, so we can use the equilateral triangle method as well. So if I use the equilateral triangle method, each angle will be pi upon 3 radians. Now, as this is 20 and this is 20 and the angle is pi upon 3, which means that if this length is 20 and this length is 20, this angle will also be pi upon 3. In part B, we have to find the length of the rope. So the length of the rope is the rope is around this whole shape. Now we can divide this into 6 different parts. So let's say each circle will have a sector. So we can make a line to make a sector for each of these. So let's say if I make a line around each of these circles, I will have six sectors, and each of these sectors will have an angle of pi upon 3, and the length will be 20 centimeters. So making a sector around each of these circles, I will have a total of 6 sectors. We can first find the arc length around each of these sectors and then find the straight length rope, the length of the straight lines. Now the arc length is given by the formula S is equals to R theta. The angle R is 20 and theta is pi by 3. So that will become 20 pi upon 3. As there are 6 arcs, so the total arc length will become 20 pi upon 3 multiplied by 6, which is equals to 40 pi. Now, for the straight length of the rope, we can see that the length from A to this point will be 20 plus 20. So this whole length will be 40, which means that the straight lengths or the straight lines each have a length of 40. So we'll multiply this 40 by 6, which will be equals to 240. So the total length will be equals to 40 pi plus 240 centimeters. In part C, it is asking us to find the area of the hexagon A, B, C, D, E, F, giving our answer in terms of root 3. Now, to find the area of the sector A, B, C, D, E, F, we can make first straight lines to join each of the centers to make a hexagon. So we have joined ED up here, we have joined BC, we can join EF, and then finally we'll join CD up here to make a hexagon. Now, once we have made the hexagon, we can divide it into 2 parts. So let's remove these lines. If I draw a line to divide it into 2 parts, we can see that they're forming 2 trapeziums. And each of these trapeziums will have a parallel length, 2 parallel lengths. So one of the parallel lengths will be 20 plus 20. So the upper length, in this case, will have a length of 40 centimeters. And as each of these lengths, this is 20, this is 20, and the diameter is 40. So the total length up here will become 80 centimeters. And this length is 40. So we have the length of the 2 parallel sides. To find the height of the trapezium, we can use sine or cos or tan, but as the hypotenuse over here, the length from A till F will be 40, as the radius is 20 and its angle is pi upon 3. So to find the height, we will use sine theta, So the height of the trapezium will be sine of pi upon 3 will be is equals to h upon 40, which means that h will be equals to 40 multiplied by sine pi upon 3, which is root 3 upon 2. We can write the height of the trapezium as 20 root 3. Now finding the area of trapezium, that will be equals to 1 upon 2 into the sum of parallel sides, which is 20 plus 40 multiplied by 20 root 3. And then the total area will become 2 times this answer. So this will be 2 times 1 upon 2 into, so this was, one of the lengths was 80 and the other length was 40. So this will be 120 multiplied by 20 root 3. 2 and 2 will cancel. 120 times 20 will become 2400 root 3 centimeters squared. In part D, we have to find the area of the complete region enclosed by the rope. Now we already have the area of the trapezium, which was in between. Now to find the remaining area, we can see that we'll have 1, 2, 3, 4, 5, and 6 sectors. And 6 sectors, and there will be 6 rectangles, as we have one rectangle up here, the second one, third one, fourth one, fifth one, and sixth one. Now each of the rectangles have this length as 40, and as this length is the radius, which is 20. So first finding the area of one triangle. So area of a rectangle, sorry, it will be a rectangle. So that will be 40 multiplied by 20, which is equals to 800. And then area of 6 rectangles will be equals to 800 multiplied by 6. So that will be 4800 centimeters squared. Now finally finding the area of each sector. So area of a sector is given by the formula half r squared theta. So we know that theta in each case is pi by 3 and the radius is 20. So the area will be 1 upon 2 into 20 squared into pi by 3. Simplifying this will become 400 pi upon 6. And as there are 6 sectors, so the area of 6 sectors will be equals to 400 pi upon 6 multiplied by 6. Cancelling this, the total area of the 6 sectors will be 400 pi. Finally, the total area for the region enclosed by the rope will be equals to the area of the hexagon that we found in the previous part, which was 2400 root 3, plus the area of 6 rectangles, which is 4800, plus the area of 6 sectors, which is 400 pi centimeters squared. We can substitute these values in the calculator and give our answer in 3 significant figures. So the final answer will become 10,200 centimeters squared.